Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today we're diving deep into the HuggingFace project, open-r1, a fully open reproduction of DeepSeek-R1. It's a fascinating project, aiming to make the powerful DeepSeek-R1 model accessible to everyone. Exciting stuff!
Absolutely. So the core goal is reproducibility, right? Making it so anyone can train and use this advanced reasoning model?
Precisely! The project's cleverly structured. They've broken down the process into manageable chunks. First, they're replicating the R1 distill models by distilling a high-quality corpus from the original DeepSeek-R1. Think of it as creating a smaller, more efficient version of the original.
I see. And then, what's the next stage in their plan of attack?
Next, they tackle the pure reinforcement learning, RL, pipeline used to create R10. This is where things get really interesting. They'll need to curate new, large-scale datasets for math, reasoning, and code. A huge undertaking!
A massive dataset. That sounds resource-intensive. What about the third step?
Step 3 is all about demonstrating the transition from a base model to an RL-tuned model through multi-stage training. They want to show the whole process, from start to finish, is replicable. It's a complete end-to-end demonstration.
So practically, how do they achieve this? What tools and techniques are they using?
They're using a variety of tools. The code is primarily in Python, and they leverage libraries like VLLM, Accelerate, and LightVal. They're also using DeepSpeed for efficient training on large models. And they're integrating with HuggingFace Hub for model and dataset sharing. It's a pretty comprehensive tech stack.
I noticed they mentioned different training methods like DDP and DeepSpeed 0-2 and 0-3. What's the difference and why the choice?
Good question. DDP, or data parallelism, distributes the data across multiple GPUs. DeepSpeed 0, on the other hand, uses more advanced techniques to distribute the model parameters and optimizer states, allowing for training of much larger models. They offer different trade-offs in terms of scalability and memory efficiency. The choice depends on the hardware and model size.
Makes sense. And what about evaluation? How do they assess the performance of these models?
They use LightVal, a powerful evaluation tool. With custom tasks defined in their code, they can run evaluations on single GPUs, or use data or tensor parallelism for larger models, scaling across multiple GPUs. They're also using established benchmarks like AIME24.
Impressive! And data generation? How do they create synthetic data to further train and evaluate their models?
They use Distillable, a library for data augmentation and generation. They provide examples of generating data from both smaller distilled R1 models and the full DeepSeek-R1, showcasing different approaches depending on resource availability. They even provide a sample dataset on HuggingFace.
That's really comprehensive. It seems like they've thought of everything. This project is a great example of open-source collaboration, making advanced ATI research more accessible.
Absolutely. The open nature of this project is key. It allows for community contributions and improvements, accelerating the progress in this field. It's a fantastic resource for researchers and developers alike. A truly remarkable achievement.
Definitely. Thanks for breaking down this exciting project for us. It's clear that open-r1 is poised to have a significant impact on the field of large language models and reasoning.
My pleasure. And that's all the time we have for today's Tech Bytes and News. Thanks for tuning in, and we'll catch you next time with more exciting developments in the world of technology. Goodbye.
Bye-bye.